I'm recording again from the beginning. See, verify the properties of relation. The last class we discussed 4 properties. The first property we said reflexive. For reflexive, we said if I take the element A, that is if I have 1, then I am going to check whether 1 comma 1 exists or not. Like this, I am going to check all the pairs in the given set. I am going to check all the pairs in the given set. Next, the next property is called symmetric. The meaning of symmetric, if I take A comma B, then I should have the opposite symbol B comma A also. If I have A comma B, then I should have the opposite B comma A also in the set. If I have, then it is called symmetric. If I don't have, then we are going to write this is not symmetric. Then the next one is called anti-symmetric. It is symmetric, A comma B, B comma A exists, but only when I am having A is equal to A exists, A is equal to B, when my both the terms are same. Or in the other way, we can define this is reflexive. When they are reflexive, then we can say that exists. And finally, we are having transitive. The meaning of transitive, if I take A comma B and if I take B comma C, if I find these two elements, if I cancel the common number BB, then I should have A comma C exists in the set. I should have B comma C exists in the set. Now here I am having the property, here having a problem. I am having A is equal to 1, 2, 3, 4 and the relation R is defined as 1 comma 1, 1 comma 2, 1 comma 4, 2 comma 2, 3 comma 3, 4 comma 1, 4 comma 4. I am going to check all the 4 properties one by one. The first property is reflexive. The meaning of reflexive, in A I am having 1, 2, 3, 4. So I am going to check the 4 pairs. What are all the 4 pairs? I am going to check whether I have 1 comma 1. This is first pair because I have 1 comma 1. Then I am going to check 2 comma 2 because the next number is 2. So I am going to check what is 2 comma 2. I am going to check the next one 3 comma 3. I am going to check the next number 4 comma 4. I am going to check whether these numbers, these pairs exist in the set or not. I am going to check here. I am having 1 comma 1. Yes, I have 1 comma 1. Next, I am going to check 2 comma 2. Yes, 2 comma 2 exists. Next, I am going to check the next 3 comma 3. Yes, 3 comma 3 exists. Like this, I am going to check one by one. I am going to check one by one. Next, I am going to check 4 comma 4. Yes, 4 comma 4 exists. When I check here, I found all the 4 elements, all the 4 pairs exist in the set. So I can say 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 belongs to the set of. If I have all the pairs, I am going to write R is reflexive. If I have all the 4 pairs, I am going to write R is reflexive. If any one is missing, we can say it is not reflexive. Even if any one statement is or any one pair is missing, we are going to say R is not reflexive. Understand the idea, dear? What is the meaning of reflexive? I am going to check the pairs. I am going to check the same numbers. That is called reflexive. But when we come for symmetric, I am going to check if I take A comma B, I am going to check the reverse. I am going to check the reverse. What is the meaning of reverse? B comma B. I am going to check for each pair, dear. If I take 1 comma 1, if I take 1 comma 1, what is the opposite pair? This is same 1 comma 1, isn't it? If I take 1 comma 1, if I take 1 comma 1, then the opposite pair is again 1 comma 1. So no problem, 1 comma 1 exists. 1 comma 1 exists. Next, I am going to check 1, comma 2. When I take 1, comma 2, I am going to check what is the opposite. What is the opposite pair? Then I should check 2, comma 1. I should check 2, comma 1. Here I am having 1, comma 2. I am going to check the other pair. I am going to check the other pair. The meaning of other pair, opposite pair, which is called 2, comma 1. I am going to check here, do I have 2, comma 1? No, I have only 2, comma 2. There is no 2, comma 1. So I can say 2, comma 1 does not exist. 2, comma 1 does not exist. As it does not exist, I am going to say this is not symmetric. This is not symmetric. If it exists, I have to go to the next one, dear. If it exists, then I have to go to the next one. If it does not exist, I can finish the problem there itself. I can finish the problem there itself. Now I am going to check the next idea, which is called anti-symmetric. The meaning of anti-symmetric, I am going to check whether A, comma B belongs to R and B, comma A belongs to R if and only if A is equal to B. If and only if A is equal to B. Now, is it A, comma B belongs to A and B, comma A belongs to R? When I check this, I found I am not having the value for 1, comma 2. I don't have 2, comma 1. Now, I am going to check here. Does it exist? And then is it only for 1, comma 1, 1, comma 2, sorry, 1, comma 1, 2, comma 2, 3, comma 3, 4, comma 4. Isn't it? I have this only this part because the meaning of A is equal to B. What is the meaning of A is equal to B? My A and B values, both the numbers, my first number and the second number should be equal. I am going to check whether I have the same pairs or not. Yes, 1, comma 1 exists, 2, comma 2 exists, 3, comma 3 exists, and 4, comma 4 exists. If I have all the same pair, then I can say this is symmetric. This is anti-symmetric. This is anti-symmetric. Even if any one pair is missing, we are going to say this is not anti-symmetric. This is very simple, basic principle, dear. Just from the number, whether the particular set exists or not, just you are going to check. Already everything will be given to you. Just you are going to check the condition. Just you are going to check the condition. The next one is called transitive. The next one is called transitive. The meaning of transitive, if I take, see, you can forget about the symmetrics, the same term, 1, 1, 2, 2, 3, 3, 4, 4, because this is same numbers you will get repeated. I am going to check the other numbers. I am going to check the other numbers. When I take 1, comma 2, I am going to take all the pairs starting from the second number. I am going to take all the pairs starting from the second number. What is the second number here? 2. What is the second number here? 2. I am going to check which pairs are starting from 2. I am having only one pair, which is 2, comma 2 starting from 2, isn't it? 1, comma 2. When I take 1, comma 2, I am having only one pair, 2, comma 2 starting from 2. So I am going to cancel the common number 2, comma 2 I am having. So I am going to cancel the common number. When I cancel the common number, I am going to take the first number. What is the first number here? 1. What is the last number? 2. Isn't it? What is the last number? 2. So I am going to check whether 1, comma 2 belongs to the pair or not, or not. When I check here, I have 1, comma 2. Yes. In the same idea, we have to proceed for all the values. We have to proceed for all the values. I am going to take the next pair. What is the next pair? 1, comma 4. Here it is ending with the 4. So I am going to check the pairs that are starting with the 4. This is called transitive. Here when I check here, I am having 2 pairs starting with the 4. I am going to check for both the numbers 1, comma 4. When I take 1, comma 4, what is the first pair I am having? 4, comma 1. 4, comma 1. So I'm going to cancel the common number. I'm going to cancel 4, 4. I'm going to check the first number and last number. What is the first number here? The first number is 1. And what is the last number? 1. First number is 1 and the last number is 1. I'm going to check whether this 1, 1 exists. Yes, this is also exists. When I check here, I can find 1, 1. In the same idea, when I take 1, 4, we said 4, 4. We are having another pair, 4, 4. So what is the first number? 1. Here, what is the last number? 4. So this is 1, 4. This is also exists. Dear, like this, you have to check. If it is yes, you have to take all the pairs. If it is no, you can finish immediately. You can finish immediately. No means you can write the answer not. This is not the correct answer. This is not transitive. The property is not satisfied. You can say directly the property is not satisfied. Now I am going to take the next 2, 2, 3, 3. I said no need to take the similar pair. I am going to check the next one, 4, 1. When I take 4, 1, here the number is finishing with 1. So I am going to check which numbers are starting with 1. Here when I check how many numbers starting with 1, I am having 1, 1 pair starting with 1, and I am having another pair 1, 2 starting with 1. So I am going to check for both the pairs. When I take 4, 1, my other alternative pair is 1, 1. I am going to take 4, 1. I am going to take the number starting from 1, 1, 1. So 4, 1. I am going to check, does it exist here? Yes, 4, 1 exists. The same idea, I am going to take 4, 1. What is the next pair? 1, 2. I am going to cancel the common number 1, 1. I am going to cancel the common number 1, 1, and I am going to check the pair 4, 2. When I check here, I am having 4, 1, 4, 4. We don't have 4, 2. So we are going to write, no, this does not exist. Even if one pair is not existing, then we are going to say this is not transitive. We are going to say this is not transitive. So the basic idea, you have to remember the general principle, the rules. You have to remember the rules. We are having 4 rules. One for reflexive, where A, A is belongs to R. When I take one pair, I should have the similar pair in the set, which is called reflexive. In the same idea, we are going to check symmetric. When we check for symmetric, if I have A, B, I should have the opposite pair B, A. This is called a symmetric. The third one, anti-symmetric. If I have A, B and B, A, where my numbers or terms are same. If I have only the reflexive pair, when I have only the reflexive pair. And the last one is called transitive. When I have A, B and B, C, if I cancel the common term B, B, I should get the remaining pair R, A, C. I should get the remaining pair. Dear, don't write anything on the screen. Don't write, please, because it is recording, dear. Remember, this is recording. Okay. I know this, you may not understand sometime. I will check with one more problem, dear. We will do one thing. The time is going to finish. We will do one thing, dear. Please log out and log in again. Okay. We will continue the problem. We will log out of this and we will come back again, dear, using the same one. Okay. Everybody join again. I will explain one more problem so that you can understand the idea.